Okay, question 25 on the math subject GRE practice test. I don't know if there's a problem on this entire test that I'm better qualified to answer. I just finished teaching Pre-Calc 1 and Pre-Calc 2 remotely over the summer. This question right here is a very standard Pre-Calc 2 question, section 6.1 in our book, not that you care. But really it just comes from Pre-Calc 1. It's just function transformations kind of in disguise. But anyways, attacking this as though it's a Pre-Calc 2 question, what I like to do for these transformations of sine and cosine is pick one complete revolution of that graph. So for this specific graph, I'm really going to focus on this part in blue right here from 0.5 to 1.5 pi. What are we doing? How about pi over 2 up to 3 pi over 2? Anyways, when I look at this graph, I'm not going to get confused by all the extra information. I'm just focusing on this red box right here. Why this specific red box? Well, I want one full revolution of the graph, and I want to kind of start, in big old air quotes, when the graph is at one of its maximums. Because if you think about just the graph of y equals cosine of x, it starts up at one of its maximums. And what I want to do is write this graph as a transformation of this graph. If I weren't transforming cosine and was instead transforming sine, I'd look for one full revolution that starts out on the midline and starts out going up. So I don't know, maybe from right here, one full revolution would take me to right here. But I'm not transforming sine, I'm transforming cosine, so I'm focusing on this part. It's worth pointing out that these graphs that I just drew right here help you draw the rectangle that you want to focus on if you have what I refer to as the normal orientation. And you'll always have normal orientation anytime your leading coefficient here, the a, is positive. So in this specific problem, it says that a, omega and phi, I think, are non-negative constants. A is clearly not 0, or this function would just be equal to 0 everywhere. So a is positive, I have the normal orientation. I'll talk about what to do if a is less than 0, even though that doesn't happen in this problem towards the end of the video. Okay, so we have our box drawn that we're going to kind of focus on. From this box, you want to identify 4 things: the amplitude, the midline, the period, and the phase shift. The first two, the amplitude and the midline, kind of refer to vertical aspects of this graph, and the period and the phase shift refer to horizontal aspects of this graph. The midline, as the name suggests, is just kind of the average height of the graph, using the term average a little bit loosely here, but hopefully you get the point. In this case, since the maximum is 3 and the minimum is -3, the midline is just at 0. Or if you were an unfortunate student in one of my classes, you might write that the equation of the midline is y equals 0, whatever. From the midline, we can easily figure out the amplitude. The amplitude is just the distance from the midline to the max or the min. So the distance from 0 up to 3 is just 3. I've identified all the important vertical characteristics of this graph. The period and the phase shift, the horizontal aspects of this graph that I want to identify, are just as easy to find. The period is just the distance in the x direction it takes to do one full revolution. In other words, the width of my little rectangle here. Well, my rectangle goes from pi over 2 to 3 pi over 2. So the period is just pi. And then finally, the phase shift. All the phase shift is the x coordinate of the left edge of my rectangle. So this point right here, in this case, it's pi over 2. It's worth pointing out that you kind of have the freedom to choose whatever phase shift you want, right? I chose this as one full revolution because that was the only pictured full revolution. But if I continue the graph a little bit, I get another full revolution over here. And there's no reason I couldn't have drawn my red rectangle to be something like what you see pictured in brown out here. Note that wouldn't change the amplitude nor the midline, nor would it change the period, but it would change my phase shift. My phase shift would now be 3 pi over 2. And there's infinitely many other choices of phase shift that you can choose. That's why this question is stated with this word could here, which the following could be the value of phi. There's no set answer for what phi would have to be from this graph. There's infinitely many solutions. But don't worry, we'll touch more on that later. If you're able to identify these 4 key characteristics of this graph, you can come up with the equation of the graph pretty easily. The symbols that I would use, maybe because I'm not Greek, would be a cosine of bx plus c plus d. We can figure out the value of each of these 4 letters just by looking at amplitude, midline, period, and phase shift. Low-hanging fruit. The midline is always just equal to d. In this case, the midline is 0, so d is 0, which is why they didn't choose some other Greek letter here at the end. Plus, I don't know, theta, sure. Not relevant to this specific problem, but maybe you can imagine a similar problem that's shifted up and you're asked to figure out A, B, C, and D or something. The amplitude, you might be thinking that that's A. It's not A, it's the absolute value of A. So the fact that the amplitude is 3 does not tell me A is 3. It tells me that A is either 3 or -3. We get to choose whether we want A to be +3 or -3 based on the orientation that we're using. If we have this normal orientation like you see pictured right here, then A is positive, so A is equal to 3. But again, maybe you can imagine a different problem where our rectangle goes from 0 out to pi, in which case we still have one full revolution, midline still 0, amplitude still 3, but because it has the reverse orientation, right? It doesn't start out at the top like cosine's supposed to. It starts out down at the bottom. That would mean that a is less than 0, so a would have been equal to -3. Get the normal orientation when a is greater than 0, and yeah, sure, I'll squeeze it in here. We get the reverse orientation when a is less than 0. So a cosine graph where you start out down at the bottom, or a sine graph where you start in the middle, but you start by going down instead of going up. Again, not relevant to this problem, but the goal of these videos is to prepare you for any problem, not just the one that's presented. Anyways, in this case, because the amplitude was 3, we know that the absolute value of a is 3. So we know that a is either +3 or -3. We get to choose what we want it to be equal to based on what box we choose when we draw one full revolution of our graph. In this specific problem, we were instructed that a is a non-negative constant, so we had to choose a box where we started out up at the top. Generally, you don't have to. We got a and d. We can move on to b and c. The period is the easier of the two. The period is always 2 pi divided by b. Technically, it's 2 pi divided by the absolute value of b. But the standard for most books is to choose that b is a positive number, in which case we can just make it 2 pi over b. Remembering from my box that the period was pi, I got that pi is equal to 2 pi over b. So if I multiply the b up here, b pi equals 2 pi. Sure looks like b is equal to 2. Divide both sides by pi if you want. We've used the amplitude, the midline, and the period to figure out a, d, and b respectively. The one thing we haven't used is the phase shift. The one thing we haven't figured out is c. Time to do that. Phase shift is always -c divided by b. Remembering that the phase shift is what you choose for the left edge of your rectangle here. We know, I don't know, down here maybe. I don't know why I'm squeezing these all in up here when I copied these onto a Word doc just so I'd have all this extra room. -c over b is equal to pi over 2. Remember, we've already figured out that b is equal to 2, so -c over 2 is equal to pi over 2. Might be able to just look at this and tell that c is -pi. If not, multiply both sides by 2, divide by -2, and you get that c is -pi. We can add that to our list up here. We got all the information we need to write the equation of this function. F of x equals a, in other words 3, cosine of b, which is 2, x plus c plus -pi plus 0. Question didn't ask for the entire equation, although it certainly could have. The question just asked for the value of, I'm pretty sure this is phi. It's going to be funny if I've been saying the wrong Greek letter this whole video. Phi is what's written right here. You might think it's -pi, but it's not because they already include the negative for you. It's just pi. Answer to this question is D. Some comments. I think this is the best way to do these problems. Yes, I gave you a lot more information than you need for this specific problem, but I think it's a good idea to understand amplitude, midline, period, and phase shift, because we're not trying to answer 25 on the practice test. We're trying to answer any transformation of sine or cosine on your actual test. But if you really wanted to, you could answer this question without any of this stuff. You could recognize that a f of bx plus c plus d just represents function transformations. 2 of the letters correspond with vertical transformations. You first apply the a, which tells you to multiply all the y values by a. You may have heard stretch vertically by a factor of a, but I think it's easier to think about it this way, because that way if a is negative, you don't have to think about it as a reflection and a stretch. You can just multiply all the old y values by a. And your second vertical transformation is to add d to all the y values. Again, you may have heard of it as shift up or shift down, which is true. That's what's going on geometrically, but this might be a little bit easier. If you have both transformations within a single problem, it's important that you do 1 before 2. Yeah, that makes sense. Of course, I multiply before I add. I memorized PEMDAS way back in the day, right? Order of operations, you multiply before you add. There's also 2 horizontal transformations. I'm going to number them 1 and 2 because it doesn't matter if you apply your horizontals before your verticals or your verticals before your horizontals. You just have to have the proper order within each category. You're probably thinking I'm going to write something about b right here, because of course you do. You multiply before you add. I'm not going to. Horizontal transformations are always backwards. At least that's what I tell my students. It's an easy way to remember this. You'd think you should do b before c, but you're not going to. You're going to do c before b. Why? Because they're horizontal, so they're backwards. Okay, cool. They're horizontal transformations, so I bet I copy something almost exactly what I wrote right here, except instead of writing y's, I write x's. Almost. See this plus c right here? Probably thinking you should add c to all the x coordinates, but you're not going to. You're going to subtract c from all the x coordinates. Why subtract? Because horizontal transformations are backwards. Yeah, there's a better answer, but most students are satisfied with me just harping on this idea. Finally, I'm going to apply the transformation corresponding with this b. Probably think I should multiply all the x values by b, but I'm not going to. I'm going to divide all the x values by b. Why? That's why. If you understand function transformations in this way, then you can go back up to this problem and recognize that this is really just the c in this transformation. So you might be like, wait a minute, the c is how much I subtract from the x values. So I should subtract negative phi. In other words, add phi to all the x values. So the x value that started out up here with an x coordinate of 0 ended up over here with an x coordinate of pi over 2, it sure looks like I added pi over 2 to all the different x values. Well, no, you didn't, because if you go back down to our transformations here, you have to apply both of the horizontal transformations. And after you subtract negative phi, in other words, add phi to all the x values, you got to divide all your x values by b. B is this omega here. In order to determine what this is, we kind of need to understand what this is. How much did we divide all of our x values by after we subtracted negative phi? Well, it'll turn out we divided them all by 2. It'll turn out what really happened here is this point that was at 0, we added a full pi to it to move it over here to pi, and then we divided it by 2, which brought it back over here to pi over 2. How do I know we divided by 2? Because this graph got all scrunched up, right? When I think about the graph of cosine of x, it's supposed to take a distance of 2 pi to repeat. But it didn't. It only takes a distance of 1 pi to repeat. Another way of saying that is the period is pi. So because this graph got scrunched up by a factor of 2, I know that omega here must be equal to 2. And if omega is 2, then phi must be equal to pi. I must add a full pi before dividing it by 2 if I want to end up over here. Anyways, the point of all that is, yeah, you can get around this without considering amplitude, midline, period, and phase shift, but I think kind of the gymnastics that you have to do considering all these different transformations is harder than just kind of doing it this way. One final comment, then I'll end this video. This is not the only equation that represents this graph. As I mentioned before, there's no reason I couldn't draw my box somewhere over here to catch the entire revolution that starts at 3 pi over 2 and ends at 5 pi over 2. If I had done things this way, my amplitude's the same, I still have my normal orientation, my midline's the same, A and D are the exact same, my period's the same, therefore B is the exact same. What I'm saying is f of x would still be equal to 3 times the cosine of 2x something plus 0. What would change is that something. Why? Because if my box starts over here, then the phase shift is no longer pi over 2. The phase shift is now 3 pi over 2. So down here where I'm solving for c, instead of saying negative c over b equals pi over 2, I would have said negative c over b equals 3 pi over 2. And if I did all that, I would have figured out that c is equal to negative 3 pi. The graph of f of x equals 3 cosine of 2x minus 3 pi plus 0 is this exact same graph that you see pictured here. The only difference is we chose a different phase shift because we're focusing on a different entire revolution. Oh, so there's 2 different answers? No, there's infinitely many different answers because there's another box somewhere out here. And you're like, okay, at least I understand what all the equations look like. No, not even close, because there's yet another box, I don't know, right here. I'm really beating the hell out of this picture, huh? Can you even see that? The box that starts at pi and ends at 2 pi? What would our equation look like if we considered this revolution here? You're like, all right, I get the point. Everything's the same except for the phase shift. And the phase shift now is pi, so I solve using that. No, because now we're starting out down at the bottom here. We now have the reverse orientation. So while the amplitude is still 3, A is no longer 3, A is negative 3. The midline's still the same, so I still have this plus 0 that I really don't even need to write at the end. The period's still the same, so I still have a 2x right here. But again, my phase shift is different. If I chose this as my box, hard to see, the left edge of my box is at pi, so negative c over b must be equal to pi this time. Since b is equal to 2, I get that c is equal to negative 2 pi. What I'm saying is yet another possible equation for this graph is this one here. You want one more? Probably don't want one more, but I'm gonna give you one more. What if I chose this box right here? This box in green has a left endpoint of 1/4 pi. In other words, pi over 4. So that's definitely going to mess up my phase shift. But before we even get to that point, we're thinking about the orientation. And you're like, uh-oh, you screwed up. You didn't start at the top or the bottom. You started in the middle for some weird reason. Yeah, it's totally fine to start in the middle. Then we're just modeling the equation with sine instead of cosine. If we start in the middle and we start out by going up, we have the normal orientation. So I put a positive 3 out here. If I'm choosing pi over 4 as my phase shift, I no longer write cosine. I'm now modeling this with a transformation of sine. My period is still equal to pi, so b is still equal to 2. My midline is still equal to 0, so I still have this unnecessary plus 0 at the end here. Finally, the phase shift. The phase shift is pi over 4. The phase shift is always negative c over b. B is still 2. Solve this equation and then you get that c is what, negative pi over 2? Yet another equation that produces this exact same graph is what you see pictured down here. And I won't do it, but instead of making the phase shift pi over 2, if I made the phase shift 3 pi over 2, I'd again model it with sine because I'm starting out in the middle, but now I'd have the negative orientation. So you can come up with an equation that starts with negative 3 sine of some stuff. A lot more than you need for this problem, but hopefully that's a pretty solid review of transformations of sines and cosines for you.